Добрый день, Артем. Я хотела спросить, если я через браузер запустила Zoom, как бы сделать эту фон, который мне прислали, как у вас?
Там, по идее, должно быть настройка камеры.
Не слышу. Не слышу, Артем, еще раз.
Там, по идее, должна быть настройка камеры. Точно так же, как и в десктопной версии.
Очень плохо вас слышно.
Там должна быть настройка камеры, по идее.
Я, например, ничего не понимаю. Настройки камеры.
А меня слышно?
Да, Татьяна Владимировна, добрый день.
Здравствуйте.
Сейчас попробую.
Всем добрый день.
Ой, здравствуйте.
Качество связи, конечно, не очень. Прерывается все. Непонятно. Это персональная проблема?
Мне кажется,
Добрый день.
Вообще не включишь. Всех получилось, у меня нет.
time is 1 hour p.m. Moscow time, and I think it's time to start.
Oh, so can I start now?
Yes, we can start.
So can you see my PPT?
Yes.
Okay. So hello, I'm from the Republic of Korea, and today I will introduce our research fog harvester using stainless steel wire. So this photo shows the beautiful scenery of the southern coast of Korea with dense fog, which is the subject of our research. So unfortunately, the other member is sick now, so he couldn't attend, and I'm the only presenter today. And I ask you for your understanding regarding this matter. Currently, people all over the world are suffering from water shortages. This picture directly shows the current status of the world's drinking water supply. Not only Africa and the Middle East region, but also Southeast and Southwest Asian countries which have rich precipitation have a serious problem with safe drinking water supplies. This is a picture of fog collecting cloud fisher net on Mount Boutmets-Goïta, Morocco. Recently, fog collecting cloud fisher nets have been suggested as an alternative to provide clean and safe water to coastal and dry mountainous areas. As this video shows, fog collecting cloud fisher nets collect water through the process of water vapor condensation into a net type fog collector and flowing down under gravity. This research started the aim to propose an effective fog catching device to solve the water shortage problem in Korea's remote and less accessible regions. According to data from the Korea Maritime Institute in 2010, Korea is the world's first country with many islands. An island is a representative area that has a water shortage. But there is a limit to the national budget to solve the water supply of the island where relatively few residents live. In addition, the method using groundwater by penetrating more than 90 meters of irrigation has a problem that when a drought occurs, seawater can fill up the groundwater zone and flows in. Therefore, a fog collector can be a great alternative to provide clean water for the islands. I think this is the research that can be considered useful not only in Korea, but also to island countries or the countries that have islands all over the world. And there is one problem that we should consider. And as we can see in this picture, fog collector is very vulnerable to strong winds because it has a grid shaped net like A or A and B, or the form of long fibers such as C and D. As shown in this picture, the part that connects the iron frame is unbearable and torn, or the middle part is torn apart, not able to withstand the pressure caused by the wind. This is the picture of a fog collector in Chile, torn by the wind. So to remedy this limit, a new form of fog collector with thin metal lines positioned in a hard form parallel has been actively studied in the Department of Industrial Design of Virginia Tech. And our team were interested in this new form of collector and focused on the point that metal is an electrically charged conductor. And we thought it was a good point to improve the efficiency of fog collecting and hypothesized that intermittent electricity supply could further increase the collection efficiency of water vapor and attempted to verify it. And current fog collecting devices have shown these three problems. Firstly, they have only been able to catch 10% of fogs. And secondly, the absolute amount of water caught during the clear and dry days is small. Lastly, winds can easily destroy the netting for fog catching made of synthetic fibers. So how can we increase the efficacy of fog collector? We focused on the fact that metals are conductors that carry electricity. Therefore, intermittent electricity supply will further increase the collection efficiency of water vapor. We are also working on designing fog collectors that can be stored temporarily by applying industrial design elements. Also, we are going to conduct a study to verify its efficiency through wind tunnel experiments too. So candidate wire materials for fog catcher were mainly nylon and Teflon. For stainless steel wire, 4 types of varying thickness, all covered in nylon, were considered. All of them were stranded, and the maximum load 60, 70, 90, and 120 lbs. All of the Teflon wrapped wires were solid core cables. They included the AWG 26, 28, and 30. The ultrasonic humidifier, which has a maximum spray volume of 450 milliliter per hour, was connected using a 90-degree socket with a length of 15 centimeter and 80 centimeter wide PVC pipes, and the maximum spray volume was adjusted using a standard 25A 40A light socket. To measure the fog catching efficacy of the candidate wire, each of the candidate wires was fixed vertically to a stand. The artificial fog was released from an exhaust tube for 15 minutes. Under each experimental wire, a 30 milliliter receptacle was placed to collect water. These receptacles were placed on an electronic scale, which allowed for up to 0.01 gram of water to be measured. During these 15 minutes, the distance of the exhaust tube to each of the wires was 10 to 50 millimeters. The length of the wires from the bottom portion of the exhaust tube to the plastic receptacles was adjusted to 100 millimeters. The height of the electronic scale was leveled with the height of the experimental table using a support jack. This allowed for the 30 milliliter receptacle to properly catch the water dripping from the wire. Each of the candidate wires was tested 3 times to get the average and standard deviation. The environment of this experiment had an indoor temperature of 23.5 degree and relative humidity of 60%. In the process of verifying, we measured the fog catching efficacy of the candidate wire, and this video shows the process. For results, the degree of efficacy of each candidate wire in catching fog is shown as following Table 1. Teflon EFTE wire proved superior to stainless steel wire of the same diameter in catching fog. When comparing between stainless steel wires of different diameters, there wasn't any appreciable difference between those maximum load 60 lbs versus 70 lbs. The same was true between those maximum loads 90 lbs versus 120 lbs. In contrast, there was a meaningful difference when comparing stainless steel wires maximum load 60 or 70 lbs against those maximum load 90 or 120 lbs. The difference in efficacy was also apparent when comparing the AWG 26 and 28 Teflon EFTE wires. It turned out that AWG 26 was more effective on account of its thicker diameter. So for this question, it appears that a wire's thicker diameter yields more efficacy because it means a greater surface area for the fog catching to succeed. But the need to consider cost effectiveness makes wires with a shorter diameter that could still catch the same amount of fog more appealing. And even as water continuously causes static electricity to be discharged, it is advisable to find a way for direct current to intermittently guide static electricity. If successful, this may make fog catching really effective even under conditions of relatively little humidity from the fog. Teflon EFTE is we concluded that Teflon EFTE is the best synthetic material for guiding static electricity. Making a fog catching device that effectively harnesses direct current will continue to be an important topic of our research. Thank you for listening.
Can I ask a question? Thank you for presentation. Please, could you comment how this project, how this work can be extended later? What next steps for these projects, for this project?
So we ultimately wanted to design a real effective form of a fog collecting device. So we wanted to design the fog collector that can prevent damage to the collector due to strong winds such as typhoons, and make the collectors that can be unfolded and folded as needed so it can be more portable. And also we are planning to conduct an experiment, like wind tunnel experiment, by making a scale model of 1 to 20. So we can actually experiment the efficiency of the collector, fog collector.
Okay, and do you have numerical comparison of cost effectiveness of different variants that you provided?
I'm sorry, can you?
Do you have a numerical comparison of cost effectiveness of different solutions that you studied? You mean between steel, for example, wires and Teflon wires? Is it expensive or not?
I think we think Teflon wire is more a better material than stainless steel wire. Stainless steel wire better than collector wire, because stainless steel wires are used in various fields such as construction or bridges or elevators or even fishing lines, and they can be found in our daily lives easily, and they are very cheap relatively to the collector wire. So we thought it would be good to let the current flow by that material because it can be the conductor with good electricity, and also it is very cheap and it is easy to purchase in cheap.
Okay, thank you.
Yeah.
Any more questions from the jury?
I have a question.
Yes.
Thank you very much for your presentation, and I would like to ask you if you can list the total kind of applications apart from what you mentioned. Where else can this technology be used?
I think, as I mentioned in this PPT, I think the islands and the area that is suffering because of the water supply problems, they can use this technology very usefully, and yes.
Okay, and what problems do you think it can fail, or what are the risks of using this technology? Have you evaluated this? For example, what can fail in your construction that maybe you can improve in the future?
I think first, I think the problem of the fog collector that it is very vulnerable to the wind. Mm-hmm. And I think that it is the most difficult problem to solve in current technology, and I'm still a student and I have no money enough to like do many experiments. Mm-hmm. So I thought it can be the most hard problem to solve. Yes.
I didn't. Okay, so so in your ideal ideal construction, ideal device, what materials would you use for
I
it not to
use,
failure to be minimum? Yeah.
pardon?
For the failure to be minimum, what materials would you use?
Teflon wires.
Sorry. This disappeared. Maybe you can write in the chat, but that's all from me. Thank you.
Thank you.
Thank you very much. The time is up.
Mhm.
Let's move to the next participant.
I will be share my screen first. Yeah. Okay. Can we start now? Hello.
Sure.
Yeah. Okay.
Okay. Preview. Good afternoon, Board of Judges. In the International Online Forum for Scientific Youth, Step in the Future 2021. Have you ever wondered, what can we do without energy? Like today, you use a smartphone or laptop to work and you need to charge it. If the day is hot, you just turn on the air conditioner. You can also store cold drinks in the refrigerator. Almost everything we do requires energy, especially electrical energy. Next. Based on the data from the International Energy Agency, the increase in global renewable energy capacity in 2020 is 80%. It's too much. And we can see that next, the wind and solar energy are leading the world's total renewable energy sources and will continue to increase in the following years. Solar and wind energy is depending on local weather and local climatic conditions. This can cause energy production to fluctuate so that the energy entering the grid is unstable and can interfere the security of electricity supply. And to overcome this problem, an energy storage system is needed to maintain the availability of electrical energy supply. The battery is currently the most feasible and most used energy storage system. The battery has some long-term problems in its application, which will permanently damage the battery if the usage is not managed properly. These problems are overcharge, over-discharge, and overheat. And the state of charge is a key value to determining when to start charging and when to start discharging in the battery system. When this procedure goes well, overheating can be prevented, especially with the charging or discharging process, which is well managed. Based on these problems, an intelligent system is needed to predict the state of charge value to prevent overcharge, over-discharge, and overheat. Therefore, I'm Harry and my partner Adit. We are from Universitas Prasetya Mulia, Indonesia, carry out research with the title IBIS, Intelligent Battery Energy Storage System, Innovation of Automated Energy Storage Battery System based on Artificial Intelligence in the Renewable Energy Power Plants. Our objective is to create a working mechanism of the system using artificial intelligence and knowing the accuracy of the estimation using the neural network algorithm in predicting the value of state of charge. We start our research from problem analysis through literature studies from previous research related to battery problems in renewable energy generation and previous solutions. After that, we develop the design. The formula is defined for each determining variable, followed by designing a calculation procedure. Then a flowchart is made as the basis of programming logic. After that, we develop the algorithm based on the flowchart that has been made. It's implemented in the Python programming language. We use the neural network algorithm in this prediction. The last process is simulation testing. The program is run by entering the previously calculated sample data to train the algorithm in predicting stage of charge value. The error value will continue to be measured, and the program will continue to iterate until it produces the smallest error. And the programs that have been running well can be implemented and combined with decision making in accordance with the flowchart.
Okay, to show you how our system works, in this slide, we will show you the overall flowchart of our system that will give you the helicopter view of our system and all the features inside it. This overall flowchart actually contains three main parts. The first part is the neural network. This neural network is the mechanism that we use to train our algorithm as an artificial intelligence to predict the SOC value. This neural network contains three main parts. The first part is input layer that will contain all the variables that we will process on the hidden layer that will result in the prediction of the SOC value on the output layer. So the second main part is the CCCV flowchart. CCCV is the mechanism that we use on charging and discharging process. In this case, we use 5 states of CCCV that contain 4 states of constant current and 1 state of constant voltage. During the charging and discharging process, there will be a risk that will be overhead happens. To prevent that one, we create the third main part, that is cooling system. This cooling system will be run automatically when the overhead comes to make the battery temperature back to normal. So the system will be run as usual. So this is the simulation video of our system. As you can see, from this video, our system could predict the SOC value with 99% of accuracy, and also the system could determine the decision by oneself. From the value of SOC prediction, they could determine what they will do to the battery. So the next video will be same as the previous video, but this is IBIS display system. Same as the previous video, but this is on the website interface that will be used as the implemented system. So could make the admin or the user easier to manage our system when it applied to the battery. So to get the 99% of accuracy, we need to did the iteration almost 5,000 times. Then we get the highest or the best value of SOC prediction. So the conclusion of this research, the first, the system works using a neural network algorithm to predict the SOC value. Multi-state CCCV is used for the charging discharging strategy and is equipped with an automatic cooling system. The second conclusion, the neural network algorithm is successfully used to predict the SOC value with the estimation result only having an error of 1% or the accuracy almost 99%. The future work of this research and this team will conduct the future research based on the real data algorithm training on the real data from the battery measurement using sensors. The system will be integrated directly according to the flowchart, and there will be comparison with conventional battery system will be same. That's all from us. Thank you.
Thank you for your presentation, dear experts. Do you have any questions about this report?
Yes, I have a question. Hello, my name is Olga, and my question is, do you know what is it battery? What it consists from? The battery as equipment. What is it?
Thank you for the question. In the simulation, we use just the data from the literature, but in the implementation, we use the battery with lithium battery that this is electrolyte, and there is the electrode in the battery. Then we predict the stage of charge in the electrolyte for this, because all of battery in electrolyte system have a lifetime, and the lifetime will be decreased if we use recycle again and recharge again, like that.
Okay, and next question is why the temperature is higher during the time? Why battery is heating? Do you understand the question?
Erden, can you repeat the question, please?
On your slide, what the data, what that the temperature is higher and higher during the time. Yes.
Yes.
The battery, your battery is heated.
Oh yeah.
Yes. So, what is the process of heating in battery? Who heated the battery?
Thank you for the question. In the battery, overheat because the rate of charge or rate of discharge is too much. I mean, when we charge the battery, the load from energy is too much, and when we discharge the battery, the uses of the energy is too much too. And we use the current constant voltage and constant current to prevent this overheat. And the maximum of heat in the battery that the cooling system is on is 60 degrees Celsius.
Okay, thank you.
Thank you.
I have another question. Thank you for presentation. You describe algorithm for controlling charging and discharging of batteries, and it's very important. It's critical for such project to have verified model of physical object. So do you have physical experiments? Did you physical experiments with real batteries, and how did you model these batteries for your algorithm? How did you get these parameters?
Okay, thank you for the question. Now we just try to make the neural network algorithm to predict the state of charge value, and we not yet to try in the real battery, because this is we write in the future work, and this is the homework for us to make to try this algorithm in the real battery. And the design to try in the real battery is we use some sensor like voltage sensor, current sensor, and the temperature sensor to get the data from the battery when the battery is charging and discharging process. And the data will be input into the algorithm like that. And the algorithm we try with the data, the random data to algorithm is learned by this data, and we must try it in the real battery to validate what the error and what we get from the algorithm like this.
Okay, thank you. And what data did you use now in your research?
Erden, can you repeat the question, please?
I mean, you already made a neural network. What data did you use for making a neural network and for training neural network?
Okay. train the neural network and create for artificial intelligence, we're using the sample data from the recent research that did by our teachers. So we create this training model using that data. So after that, we also create the testing data using the sample data also, not live take to the battery.
Okay, thank you.
Any questions from the experts, from the participants?
I have a question, short question. Have you considered different temperature regimes? For example, if you're using a battery in Africa, it's one condition. If you're using a battery in Siberia, how would your algorithm compensate for those changes of external environment? Hello?
Okay. Thank you very much for the question. This is not yet we prevent, and we just put this temperature sensor in the battery, but in the what's the name? The temperature will be detect in the internal of battery, not in the environment. But this is there is some opportunity to the what's the name? Environment temperature will be detected too and make our data is not valid. Okay. But we must in the future we must try to prevent this problem. Any addition from Adi?
So from the technical side, this case is a unique case because the external temperature will make an impact to our sensors. But maybe to prevent it from the technical side, from the system side, there will be make a margin of error or margin was to prevent if external temperature also detected. So maybe we can make a range that the maximal temperature we turn on the cooling system.
Okay, so you can improve it in your future work, right?
Yes.
Okay. Thank you.
Thank you.
Thank you. Thank you.
We have time for one more question. Anyone?
Okay, one more question. It's Dmitry Kalinkin. Have you know about some analogs of your system?
Pardon, can you repeat the questions, please?
Do you know about some analogs of your system in electric, in other branches?
Did you study similar projects like your one?
Okay, during this research process, we also get some reference from the other research that will be similar, but not really similar with our research. Because like the mechanism of charging CCCV, we learn from the other research, but we combine it with the artificial intelligence to predict the SOC value. And also the cooling system is also from the other research, but we combine it all to one package of the system that will be complete system to manage the battery.
Thank you for your answer.
Okay.
I propose to hear the report of the next participant, Sujita from Nepal. Can you hear us?
Hello, sir.
Hello. can start.
Okay, wait a minute. Wait, it's almost time. Sir, here I've got some technical problem. Could you provide me some time? Sir, hello?
Oh, you have some technical problems?
Yes, ma'am. Could you provide me some time?
Yeah, sure.
Maybe next participant.
I propose to go on to the next speaker.
Next speaker also doesn't have electricity in his home. I think that we should wait the next participant.
Sujita, we cannot see you.
Sir, can I start?
You can start. We cannot see you. Can you turn on your screen sharing?
Okay, sir.
You can start.
Yes, sir. Okay. Respected panel of judges and all the audience present here, namaste and good afternoon. My name is Visa Kesi, representing Nepal through Brainikov Research Organizations. Today, it's my great honor to be here amongst you. And today, the topic of my presentation is aerial surveillance, where I came up with a drone for traffic management. In this project, in this presentation, I'm going to explain how my presentation will work for the country, and in futures how can it implement it. So before starting my presentations, I would like to share how I came with this idea. So let's start. Is transportation a need or want? What do you think? I believe transportation is a need and want. Both want came up with a need. Transportations establish globalizations and civilizations. It increases the economic growth of the country. Everything come up with good and bad aspects, and its bad aspect is rise in traffic congestion, which main reason is the population growth and the system unable to manage the traffic systems, which impact emergency vehicles like ambulance, fire brigade, etc., falling to reach their destination on time. As we know, what is the value of every seconds for the passengers inside that vehicles. And next one is rise in accidents. Every day, lots of accidents took place, but we hear some of them only has been traced and punished. But in majority, many cases has been closed. The main reason is the system unable to track the persons, and by observing these situations, the idea of bringing aerial vehicle drone itself became the main motive of my projects. So start with the visions and missions of my project. First one is research and data gathering. Here I do research and gather the data from internet and other resources, and designing a prototype is another objective where I implement what I am going to do in this my projects, what technology I'm going to use in this project. And next one is deploying the aerial surveillance system to monitor the traffic management activity, and finally developing the final product for the project. The visions, how where I am going to implement it, my project are in uninterrupted drive for emergency vehicle. As I mentioned, it impacts greatly in emergency vehicles. So it helps emergency vehicles to reach at the time at a right time, and save the person's life. And it also aware people about respective traffic jams to take alternative routes, which saves times as well as helps to manage the traffic systems. And criminals can be easily detained in cases like hit and run, where drone trace that persons and sends the data to the police, and they were able to catch the culprit and provide the compensation to the victim. Next, the methodology that what I did in entire project is shown here. The first one is system requirement analysis here, which includes research and development. Here, it includes every necessity that the projects require, such as the tools and technology that I am going to use in this project, and the actions, how I implement everything. Here, it represent in system requirement analysis. And next one is designing up. As I mentioned, designing a prototype. Designing plays a vital role for physical development. Here, the concept of digital twin, the virtual replica of physical assets, which work as same as the real assets, utilize and help me to work on my project effectively. Next one is implementation of technical things in proper way, which helps for better running and better configurations of the projects. And next one, after implementation, testing is done, where a command is run and it operates the DJI Telo, and see all the management, and if it works it sees if it is working or not, and if it works, that I prepare it for. And next one, it goes for deployment, the aerial surveillance for traffic management, and then maintenance, and finally maintenance is done to optimize the vehicles. Now, the tools and technology that I used for this project is DJI Telo drone. This drone is a programmable drone which contain Intel and DJI technology for its flight control, along with the camera attached on it. And there are two antennas which can helps to transport stable video transmissions. And I used this Python programming. Is a high-level programming where I wrote my all codes. And
Sorry, we lost the sound.
Sorry, hello, am I audible?
It's okay.
You can say, you can continue.
Hello?
We can hear you. You can continue.
Okay. Okay, and this Python is OpenCV. OpenCV work as the backbone for image processing, whereas DeepFace frameworks helps to identify and handle the facial recognitions. Along with TensorFlow, which trained to train DeepFace model as a personalized model. Next one is integrations. How I implemented the tools and technology and how it performs, tools and technology performs for my entire projects. First, the image of a person is get by a drone, then it sends to a police officers, and the entire thing is here two factors: drone manipulations and image processing is done. For image processing, OpenCV is used. As I said, it works as the backbone for image processing, and the DeepFace and OpenCV are merged together to create the AI that detects the persons from the database, and then drone trace that persons. It sends the data to the police station, and then the culprit can be detected. This is a small demonstration of my projects through animated video. Let's have a look. Okay. Nice. Why it's not me? So I'm not able to run this video. Okay, I have got some problem here.
You want to share video, yes?
Yeah, sir.
You should start screen sharing with effect of share sound. You can stop screen sharing and start it again, and use or correct window or the entire screen. And there should be a checkbox. share sound.
Person. Okay, did. Okay, I'll show you in last. At last. Here is the applications of the projects. Not only in traffic management, we can use air surveillance in other field, other sector also, like in enhancing network connectivity, traffic congestion monitoring, fire detections, pollution monitoring, and not only that, we can use this project for various surveillance like fire detections and others. And at last, there is ethical considerations. Everything has its own ethics, which includes how the technology is used and how it, for what purpose it is being used. One famous writer says, when we evaluate an actions, we can focus on various dimensions of actions. So when we evaluate a person's performing some tasks or actions, then the intentions and motive of the persons should be evaluated, and the nature of act itself or its consequences. So while using a drone and gathering information of some individuals, it could get invasions to privacy. Let's give an example. If we went to a park and we start to click the video, if unknowingly or accidentally that drone takes the pictures or video of strangers, that hampers the privacy of that strangers. So for utilization the drone, we have to take care of every laws and rules and policies provided by the governments. Thank you.
Thank you for your presentation, the experts. Do you have any questions about this report?
Sir?
Yes, question. Thank you for presentation. Could you please conclude what is the result of your project? What have you done besides of review?
Sir, I performed the code in Pythons where I installed the library like OpenCV, works for image processing. That drone can work for at every station, every police station, drone is placed, and where a minor accident like hitting a car and ran away, then that drone trace the persons through the database includes in deep face model.
Okay.
And the police officers could easily get the information of that person and arrest.
And have you done some experiments? Maybe some
Coding.
Hmm?
Coding. Yes, sir. I perform in DJI.
Did you do some experiments in your projects, or just theoretical research?
Sir, I click some of the video, but I could not play here.
You just can explain.
First, I took the help from YouTube and in DJI Tello. In DJI Tello, I performed the programming. That's it. Not so many experiments.
Okay, thank you.
Thank you for the question. Maria, I can see your raised hand. You can ask the question.
Hello.
Hello.
Yes, ma'am.
Can you back please to the page with integration in your presentation? With integration. Yes, this one. If I'm correctly understand, image processing providing on the device.
Ma'am.
Yes. Do you have any difficulties with this step? Because image processing is too much
It is
too
very
much hard for.
Yeah, it is
Yes.
very difficult to detect the personal face or the object that you want to detect.
Okay. Thank you very much.
Thank you for the questions. Thank you for the presentation. I propose to hear the report of the next participant from the Israel, America. Hello, Tomer.
Hello.
Hello.
Hello, you can start.
Wait, we're supposed to start at 2:20, so can I have a few minutes?
Yeah, sure.
Okay, thank you.
Dear jury members, I think that we have 5 minutes break.
Okay.
Yeah.
Thank you.
our 5-minute break is up. I think we should start. And our participant from Britain has connected. Are our experts ready? I think we should start. But we have connected participants from United Kingdom, Brandon, Michael Myers.
Okay, one second.
It is not your timetable. I asked you to give it because we have not our participants from United Kingdom. You will.
I am here.
Okay. We are sticking to timetable, and you can start now, Brandon.
Okay. Thank you. My name is Brendan Morales, and I'm in year 11. I'm 16 years old, and I'm from the Loughborough Grammar School in the UK. Sorry, I'm just going to share my screen quickly. Thank you. Over the last 2 years, wildfires have become a global issue. Pre-existing response mechanisms focus on detecting where wildfires will occur in real time, rather than where they are likely to occur. Accurate predictions would allow fire response organizations to be deployed in a more timely and effective manner, with resources allocated to areas of consistently higher risk. This project creates a system which can predict the chance of a wildfire in a certain area by harvesting and processing meteorological and socio-economic data from public sources. Using historic data available from the Met Office in the USA, coupled with processed data from the US Department of Agriculture for every known wildfire between 2010 and 2016, a machine learning can be used to calculate the likelihood of a wildfire starting in any given location, given its meteorological and socio-economic state. The Met Office provides meteorological predictions for 3 weeks in advance with high confidence. It is therefore possible to provide a statistic for the probability of a wildfire occurring in a specific area on an hourly basis for 3 weeks ahead. Given that many wildfires are started by arson or other such human factors, it is important to take socio-economic factors into consideration when generating this statistic. To do this, my system uses rudimentary natural language processing on local and national news websites, and by virtue of this, the program has achieved a final specificity of 87% and a sensitivity of 86%. To generate the algorithm for predicting wildfires, the first and most prevalent issue which needs to be addressed is the collection of data, both historic and current, which can be used to train and run the program. Given the nature of analog data, such as weather and meteorological data, I needed to find data records which were stored as an average over a certain amount of time. These would have to be the same, ideally, for the training data and the data used by the program when running. And this interval should be as low as possible for the highest accuracy. This task presented many challenges, as many sources of historic meteorological data stored past data as an average over a much larger time period than the stored data for more current circumstances. For example, many data sources would store historic data as an average over 12 hours, whereas current data would be given as an average over 1 hour. There was, however, a significant amount of historic data stored by the Weather Bureau at the relatively low time period of 1 hour, and this ended up being the historic data I used. The data which the program uses to run in real time is collected from the UK Met Office website. After collecting the meteorological data, it was necessary for me to collect data concerning when and where wildfires had occurred. Fortunately, the US Department of Agriculture has a publicly accessible archive of every known wildfire occurring in the UK. This not only allowed me to cross-reference the data stored by the Weather Bureau and the US Department of Agriculture, but also to find categories of data and locations that would be suitable for use as training data. As well as this, the data had to be processed because I'm getting weather data and not a chance of wildfires. There's no way to find a chance of wildfires given weather data. And so to generate a likelihood of a wildfire occurring from this weather data, I needed to do a lot of processing of this data in order to generate a usable statistic. So after finding the data sources, the historic data, I had to find out which wildfires occurred in each region the Weather Bureau stored data for. And this was fortunate because the data provided by the US Department of Agriculture included very specific coordinates. Using this, it was possible to find the closest point of weather data collection for each wildfire and assign it to the weather conditions which occurred at that weather station. Originally, all the wildfires listed were considered in training. However, it appeared that an increase of accuracy occurred if the wildfires originating more than about 50 kilometers away from the weather stations were ignored. And I'm constantly trying to fix this value and find an optimum distance for this. Finally, I had to create a program which would go through every occurrence of a set of weather conditions to see how many times a wildfire started under those conditions compared to the number of times they were present within the dataset without a wildfire occurring. Consequently, I was able to create a ratio for a large number of different datasets, assigning every relevant wildfire in the training data a percentage chance to go alongside the data of the weather conditions under which it started. By this method, I was able to generate 7,368 cases of weather conditions and their associated chance for wildfire occurring, which was all the required data to train this machine learning. After this, I implemented a neural network, which consisted of 6 hidden layers, each with 9 nodes in, and 7 input nodes for wind speed, precipitation, past precipitation, average temperature, minimum temperature, maximum temperature, and humidity, with 1 output node. And later, there was another input node added for socioeconomic situation of an area. The neural network used a Rayleigh activation function, as I did not know the nature of the function which gives the chance of a wildfire from the given data. And after testing with sigmoid, tanh, and other standard activation functions, the Rayleigh function gave the lowest loss for the output. And on that, the loss function used is a mean square error function, which takes the difference of the squares of the predicted value and the actual value, and then uses this value as the loss of the neural network. Originally, the loss was 3.42% in significant figures, but after the socioeconomic factor was inputted, this decreased to an average of 1.2 to 3 significant figures. As I've said earlier, many fires, both domestic and wild, are started by arson. This suggests that the socioeconomic situation of an area has a strong impact on the likelihood of wildfires occurring in that area. To find current socioeconomic data for a geographic area, I found a variety of local newspapers with an online presence and used a Python library to automatically collect their news articles. This program then searches through the articles for positive or negative statements and words using rudimentary natural language processing. By using the number of negative statements made versus the number of positive statements made about an area, it was possible to generate a ratio which could then be passed into the neural network model for current data. And a very similar method was done for collecting historic data about this. To test the accuracy of the algorithm, I used a Bland-Altman plot to see how accurate the neural network was to the first method of generating a likelihood chance. And to see how practical it would be in the real world, I used a receiver operating characteristic curve. Thank you. Do you have any questions?
Yes, I have a question.
Okay.
Do you have any case study for how your algorithm works, just to prove that it exists?
Oh yeah, sorry. So I haven't got a case study, but as I said, I have done a receiver operating characteristic curve over quite a lot of historic data. So I left out about 400 test cases from training. And I used these as real-world scenarios to use for statistical analysis. And in this, I achieved 86% and a 87% sensitivity and specificity which proves that the algorithm does work and has a lot of relevance in the real world. I've also spoken to some people from the Met Office and from local fire departments asking about how this algorithm would be implemented and whether it could be used. And they suggested integrating satellite data so that it would be accurate and would be for larger areas or more specific areas with more areas. And the Met Office gave hints and said that they would actually like to work with the algorithm in the future.
I mean, you don't show in results of your algorithm, so it's very hard.
Sorry, I can show you.
Yeah.
Sorry, I have got a program I can show you.
Okay. And the next question, what is the forecast period for your algorithm? It's like week ahead or year ahead?
It can go up to 3 weeks ahead, but and it will give you within an hour.
Okay, thank you.
Actually, Brendan, hello. Thank you for your
Hello.
presentation. I have one question related to Artyom question. So why didn't you use the cross-validation for your algorithm? Why you use just split for the train and test? Because for machine
Pardon,
learning
sorry.
methods, it's usually preferred to use cross-validation when you separate your data 5 or 10 times into test and train sets, and then obtain some ROC values and other metrics, and then average them. Why didn't you use the cross-validation method?
Sorry, could you just repeat that question? I think there's been some internet problems. I couldn't hear.
So have you used the cross-validation method for the metric calculation or not?
I have used the cross-validation method.
So
yes.
How many faults there were?
I have had I think, hold on. I don't know this off the top of my head. I'm sorry. Hang on.
Okay, so and what was the entry parameters of the model? I mean, which features do you use as the main features?
So the main features I use in the model, in the data, are the wind speed, precipitation, past precipitation, average temperature, minimum temperature, maximum temperature, and humidity. As well as the socioeconomic state of an area as the input nodes.
Yeah, okay, thank you.
Brendan, I thank you for your presentation. You know, in Russia have maybe the country which has the large concern about the fires and forest fires. Last year, just 13 million hectares of forests were burned, and that's why we have a very big program, and we have an institute who made geospatial monitoring around the all countries and maybe around the globe, where they can analyze and detect the fire as small as 1 meter. And maybe if we can use this data, I mean the geospatial data, maybe you can make a prediction more accurate. So I can make a contact with colleagues in this institute, so they can maybe you can collaborate in this regard. So it's just a comment.
Okay, thank you. And I've just looked at my report, and I use 5 folds.
Thank you.
Okay, thank you for your presentation. I propose to hear the report of the next participant. Now it's your time, Tomergat. You can start.
Hello.
If you don't mind, we would like to share a video before we begin our presentation.
Okay.
But it was all cut short.
Sadly, the terrible fantasy you just witnessed is all too real. In the United States, a child is killed every other day because of unintentional shootings. Even with the obvious risk, over 4 million children are exposed to and live in houses with unlocked, loaded firearms at any given moment. In total, over 50,000 people a year are injured as a result of unintentional shootings. Billions are spent every year on medical treatment for injuries resulting from unintentional shootings. It is undoubtedly a huge problem facing our society. While there are alleged solutions, 50,000 people a year would disagree. We're here to solve this destructive problem with a much more effective solution.
Safeguard offers a simple, effective product designed to prevent unintentional shooting accidents. The Safeguard safety measure is an electronic handgun additive which prevents unintentional shooting by automatically blocking the firing capability of the handgun when it's not in use. Our product is simple, aesthetic, and functional, as well as completely automatic.
Preserves handgun functionality. The device blocks the movement of the trigger depending on the positioning and bearings of the handgun. When the handgun is placed on a horizontal surface for a certain amount of time, the device recognizes that the handgun isn't being used. The additive is then activated, automatically blocking the trigger, thus rendering the gun non-functional and allowing no operational use of the firearm. When the handgun owner intends to use the handgun operationally, he may deactivate the device quickly with a button on the base of the device. Our product acts as an automatic safety precaution, allowing only intentional use of the handgun. Most unintentional firing accidents occur as a result of human error, when firearm owners fail to follow proper traditional safety precautions. By blocking the functionality of the firearm automatically, our product eliminates the risk of human error, significantly lowering the chances of unintentional firing of the handgun.
Our system is based on a PCB, a printed circuit board. The PCB mechanically supports the system and connects the electrical and electronic components. The components are soldered onto the PCB so that they're electronically connected and mechanically fastened. The PCB receives energy from a simple 5-volt battery and requires a very small amount of electricity. The system incorporates an Arduino microcontroller, which contains a program on code written in C#. The controller runs an Arduino platform in an open source development environment, allowing easy connection of components. The system contains a 3-dimensional gyroscopic sensor, which is used to measure the angle between a body in motion, the handgun, and a body in a horizontal position, the space on which the handgun is placed. The gyroscopic sensor located in our additive is an ICM 46288P type gyro sensor. Continuous data on the position and bearings of the handgun is derived from the gyro sensor and is then relayed to and analyzed by the controller. When the continuous data derived from the gyro sensor is fixed for a certain amount of time at a horizontal angle, the controller instructs the PCB to transmit a weak electrical pulse to a solenoid. A solenoid motor is a 3-dimensional coil that converts electrical power into motion. When a solenoid receives a very weak electric pulse, it's activated, pushing a thin metal rod called the solenoid stroke forward. Our system incorporates a push-pull 100C type solenoid. It is located next to the trigger, so that when it's activated, the stroke fits between the trigger and the handle. In such a situation, the solenoid physically blocks the movement of the trigger and does not allow firing of the handgun. When the handgun owner intends to use the weapon, it can be returned to full functionality very quickly. At the bottom of the device, below the trigger guard, there's a simple release that shuts off the solenoid. Once the solenoid is closed, the gun can be used fully and functionally. Safeguard brings groundbreaking innovation to gun safety, a traditionally non-innovative industry. Safeguard applies simple technology to a new industry, introducing a new concept of safety and a new way of saving lives. In the huge gun safety industry, the technology of our product is completely unique. There are no products on the market that set the position and angle of the gun as a condition of blocking its functionality. Our product is also unique in its blocking system, in which blocking of the trigger occurs automatically without the need for a manual operation. When our additive is connected, it allows no operational use of the handgun, ensuring 100% safety. Even so, when the handgun owner intends to use the firearm, he can quickly return the handgun to its full operational functionality. Even considering our unique technology, our simple electronic system allows us to price our product at an affordable price, at a fraction of our competitors' pricing.
When considering other competitors, safety precaution that significantly lowers the chance of unintentional shooting at an affordable price. Here we compare our products to Master Lock, who offers a manual and safe trigger lock, Calipfort, who offers a biometric magazine that requires a fingerprint to operate, and ZorX, which offers a lock for handguns that requires a code to use the handgun. In addition to our automatic system, in our low pricing, we are unique in that we offer quick return to functional use of the handgun. Additionally, our product is designed to fit the handgun aesthetically, and market for our product is the American civilian gun market. The industry is comprised of 122.1 million civilian gun owners, who hold a total of 393 million firearms. Our initial product is aimed towards handgun owners. Of the total firearms in the United States, 72 million are handguns. Our TAM, or total addressable market, in the United States is 23.6 billion, while our initial market is 4.32 billion. Internationally, we estimate our total addressable market at $51.4 billion.
Our cost structure includes cost of goods sold, estimated at a total of only $17 for components, manufacturing, and shipping. It also includes operating expenses, mainly marketing, R&D, and payrolls. Our business is potentially marginally very profitable. Our revenue stream is comprised of product sales sold at only $60 a unit for a 71.6 gross margin. Key company activities include R&D, marketing, and sales management. Our customer segments are firstly end consumers, initially American handgun owners. Another potential customer segment is insurance companies, which could buy our product to provide safety measures for their clients. Finally, we also have retail and specialty stores. Sales channels include business-to-business channels, which are retail chains, specialty stores, and insurance companies. We also have direct e-commerce sales as business-to-consumer sales. Additionally, we have the option to sell to both businesses and consumers through trade shows. Our value proposition to our customers is clear. To consumers, we offer an affordable price for an automatic-based personal safety precaution. To insurance companies, we offer the opportunity to lower client injuries, reducing payments for insurance claims. To retail or specialty stores, we offer additional products to sell in order to increase revenue. Our high gross margin also allows us to discount our price to retail stores, giving them a more significant profit margin on sales of our product. Safeguard, we have a capable team. We both study at Kfar Hayarok School, one of the top schools in Israel, in which we major in computer science and physics. We also take part in Green Start Academy for startups. We're well-versed in critical subjects, namely computer science, physics, and engineering, as well as business, finance, and economics. We're currently in the midst of filing a patent for our product and continue to develop and grow our startup. In the future, we plan to acquire funding in order to complete a quality control program, obtain security permits, and finally manufacture and launch our product. It's time for change. Safeguard, save lives.
Thank you for your presentation, dear experts. Do you have any questions about this report?
Actually, guys, thank you for your presentation. It was really interesting. Maybe it's not a question, just a major comment. I would recommend you to go to some customers, to some potential companies that you want to work with, and to ask them whether they actually need your device, and if yes, what the maximum price will be for them in order to buy your device. So it's just
before now, we also consulted with various people in the gun industry, and also in Israel and in the United States. And the ones that we consulted with at least see the value of our product. Thanks for your question. About pricing, we can be very flexible with our pricing and even lower it because of our profit margin and our low cost of manufacturing.
Yeah, okay, thank you.
Anyone?
Dmitry, you can ask your question.
The size is very important value of your device. And as I understand, you made the sample on Arduino module. Do you think, what do you think? Could it be made as small as you show the picture, including a battery?
Well, batteries, we can use very small batteries because we don't need much electricity for our product. About the Arduino operating system, we can use alternatives. It isn't specifically, we don't specifically need the Arduino operating system. We just found that it was simple to connect all our components. But if we don't think it's a problem, we're currently working on a working electronic prototype. But if we do have problems, we can easily change it without having any big issue in our product.
Okay, so you use electromagnetic pulse to move the mechanical element. There should be conditions to the battery.
Yes. Is there a specific question? Sorry.
I said that there should be requirements for the battery because of electromagnetic pulse that you should fire to move the mechanical parts of your device.
Okay, thank you.
We have time for one more question.
Okay.
I have a question. Oh, okay, Dmitry.
Okay, one question for Arthur. By making and selling this device, do you remove the responsibility from the owner of weapon?
Okay, thank you for the question. That's important because, well, we can't take responsibility, of course, because that would open us up to liability. In our policy, when we sell our product, we can include that we do not take responsibility, as do other manufacturers of gun safety precautions, to take the liability away from us.
Okay, thank you for the presentation. Thanks for questions. I propose to hear the report of the next participant.
Thank you.
From Portugal, Hugo Costa, Hugo Megaldo, Rita Matos. You can start.
Thank you. I'll share my screen. Okay. Can you see it?
Yes, we can.
Yes.
Great, thank you.
Hello, my name is Hugo Costa.
My name is Rita Matos.
And I'm Hugo Melgado.
And we are going to talk about our project, development of integrated ionizing radiation detection and alert system. Currently, health professionals of various categories, such as dentists, are exposed to a high amount of ionizing radiation, which is harmful and leads to the contraction of serious diseases, such as cancer. Thus, to better control the exposure to harmful radiation to which these professionals are subject, we present in this project an innovative system of detection and analysis of ionizing radiation. That analysis in real time, the exposed to this radiation and alert the user whenever the daily limit is reached.
So, to better understand this issue, we did a survey to dentists and we got more than 100 answers. And I selected some of the questions that I think were the most important. And we can see here that more than 80% of the professionals don't use any means of protection when they do X-ray, and that half of these dentists don't have any method of counting ionizing radiation, and the ones that have, it only transmits the counts every 3 to 3 months or every 2 months.
The developed system consists of two parts, the detector and the mobile application. While making the mobile application, we had two objectives in mind: to quick access the various parameters relative to the user exposure to ionizing radiations, and to alert the user whenever he passes the daily limit of ionizing radiation, or if he has been exposed to any radiation leak. First, the user needs to create an account or log in if he already has one. This authentication is important because the information collected throughout the session is personal and needs to be stored on a personal location in our database. Once the user logs in, you can now access all the functionalities of our application, and for example, first you'll need to connect the Bluetooth the application, the detector to the mobile application via Bluetooth, and this connection is important because we can receive the data in real time. On the session screen, the user can see, besides of the values of the radiation in real time, the elapsed time of work and the graphic that shows the evolution of ionizing radiation to which is being exposed. You can pause the session at any time or end the session, and the values will be stored on our database. Then there is the history screen that shows all the values from the previous sessions that the user recorded. The user can log out at any time, and all the data will be stored in our database. While making the application, we always had in mind an intuitive interface, thus making an effective bridge between the user and the detector. And this application was really important because we can easily show information that wasn't available to these workers in real time and alert them. And it's really important for that because we are solving an important issue.
So it was necessary to create a detector from scratch, since the detectors that already exist had their own applications, and it was impossible to make the connection between the ones that existed and our application. So to make our own, we first needed to select a certified sensor, and then the other components, such as the controller, where we use that Mega 328P, and a Bluetooth model to connect our app and our detector, which use the HC05, and an LCD and a buzzer to provide a better user experience. And after we had all the components chosen, we did a prototype in breadboard to check the entirety of the system and see the total consumption. But because the breadboard is not practical, we needed to do a PCB. And to do a PCB, we needed 3 steps: to draw the circuit, to associate footprints to symbols, which means to associate a certain type of piece with the characteristics and measures that we wanted to the symbols, and finally to create a design. After we had a PCB, we weld all the components together and add a switch, a charger, a converter, and a battery. And finally, we did a coating in plastic through 3D modeling to make the detector more practical to the day-to-day use.
We conducted about a 2-month field test with a real dentist testing our product, and the feedback that we got was really positive. As we expected, our product is practical, does not interfere with the user's work, and the values that we got were appropriate, and all the system worked correctly. And this feedback was really important because it allows us to improve certain aspects of our system. And we still want to make more of these tests, but unfortunately, due to the COVID situation, we have scheduled that for the future. Meanwhile, we've also been improving our application. We are making a new application on a new language, on a new program, and this application has more features, has more available information, and is overall more robust. Besides that, we've been improving our detector. We are changing our old microprocessor, that Mega 328, for an ESP32 that has Bluetooth inverter on it, and we are taking out some accessories like the LCD, thus making the old system smaller and further improving our battery consumption. We also want to make this an official product next to our health authorities, and use this system in real situations to save people.
So we believe that we created an innovative system because, unlike the other systems that only send data every 3 months or every month, ours sends data in real time, which is very important because radiation is an invisible problem, and the health issues that come with radiation are long-term problems. So people don't care because people don't see it. And by having daily the amount of the radiation they were exposed to, they can see better and have a better notion and prevent it. Plus, our system can also detect radiation leaks from hospital equipment, which is very, very important to detect these leaks as fast as we can. And nowadays that doesn't happen, and our system can do that. And not only saving lives from people, from workers, but also from patients that are in the hospitals at the time. So we want to thank you for listening to our presentation. You have our contact if you need something. And I don't know if we can show you our system working in real time if you want to. And we are available for questions, obviously.
So I can show you the system. We already, oops, I don't think you can see that, but this is the detector. We've already started the connector, and if I start the session, we will start getting values in real time. Oh,
they can see it.
Okay, is this better?
Yes.
You can see the value in real time, and the graph is being plotted. Right now it's really small, which is great for me, means that I'm not exposed to high radiation. But this is the system.
Okay, I have a question. Hello, thank you for your presentation. And my question is, do you know what's the principle or physical principle of counter of radiation in your device?
Sorry, I knew that you said something about the radiation, but I didn't understand really well.
You don't read about it, yes?
No, we read about it, yes, and we read the specifications of our sensor, and the radiation that he detected were specifically the radiations that, for example, dentists use in their consults.
Okay, and next question, how do you think your equipment don't need to close in some box from radiation, or about your Arduino and another elements, how they connect with radiation?
I'm sorry, I did not understand the question. Could you just repeat it on?
How radiation is influenced on another elements of your device?
I will try to answer, but I don't know if this was the question. So our sensor detects the radiation and sends the data and it has a controller from the Arduino Uno, and it controls the data that is being used and sends it, and the Bluetooth model sends it to our application. But you can also just use our detector because it shows the radiation in real time, and it has a buzzer and it alerts when the radiation limits is reached, and the application does the same too. I don't know if I answered the question, I'm sorry.
Okay, thank you.
Maybe I would rephrase the question that is the X-ray radiation influence the electronic parts of your scheme?
Oh, no,
because
no.
Yes, not only people influenced by the X-rays,
yes,
but
yes,
also
yes.
electronic. What do you think? Do you need some kind of protection for the equipment?
No, it doesn't need, because we are talking, these type of radiations don't affect our electronics. And most of the radiations that we are talking about aren't as large to make that damage. We'll see it.
Yes, and as you said, we tested this for about 2 months in a real situation, and the system is robust.
Okay, yeah, you just tested. And another question, I don't understand exactly. Do you think that this device should be brought with the doctors, or it should be kept somewhere in the room?
So it can be the both ways. So if someone wants to have a detector in a room and connect to various peoples to the same detector, they can, yes. If they want to have solo for the use, they can as well. But yes, they can have one detector per room of the doctor, let's say.
Okay, and maybe the last question. You have a very good interface with the smartphone. Why do you need the display?
The LCD.
Yes, why do you need the LCD display instead of cell phone? Because it doesn't seem as a requirement.
Yes, that's why in our new developed system we are taking out the LCD, because we figured out that it's not necessary and is consuming more energy.
Okay, thank you.
Thank you.
Okay, thank you for the question. I propose to hear the report of the next participant.
One question more, or okay.
We have time for one brief question and brief answer. 1 minute.
One question, please. In what physical units do you measure radiation?
Microsieverts.
Yes.
Thanks.
Okay, I think now we can move to our next participant from Turkey.
Thank you very much.
Yaman Has, Serenzor. You can start.
1 minute, please. Can I say something before the presentation?
Yes.
I removed my background because I will show you something in the presentation. It's suitable for you.
Yep. You can.
Okay, thank you. Okay, I opened. Yes. Hi, I am Yamanas.
Hi, I'm Jaranzor. Our project is Lifesaver Detector.
Earthquakes are natural disasters that have had very painful results in human history. It's not possible to prevent the occurrence of earthquakes or to determine the time they will occur. It's possible to minimize the damage and loss of life, especially after the earthquake. We thought of designing a device to shorten the rescue time of the people who were buried under the wreckage as a result of these earthquakes. The problems we identified accordingly: reaching people and animals under the wreckage in the shortest time, not being able to detect the people or animals under difficult wreckage conditions, and the disadvantages of currently used devices.
We designed this device to reach people alive in a short time by determining the heartbeat and respiration of the people who are under the rubble even if they were inactive. So what's an earthquake? An earthquake is the shaking of the earth by vibrations caused by breakage or rupture events occurring in the earth's crust.
Here we see the earthquake risk map in the world. According to the researchers, the probability of people's survival under the wreckage in the first half an hour is 91%. This rate decreases to about 7% at the end of the fifth day. The average survival time under wreckage is 5 to 6 days. And search and rescue dogs, acoustic signals, and human physical search and rescue are the main methods used to locate victims. Now, we have listed some devices for detecting life in earthquakes and their advantages, disadvantages. Seismic acoustic listening devices, advantages. It's possible to perceive the signals produced by victims as visual and audio, but their disadvantages: it cannot detect victims who lost their consciousness. Its use is limited in noisy environments.
Radar life detection systems advantages: it can perceive life signals of the victims without physical contact throughout the holes in the construction, even from a long distance. But disadvantages: penetration depth is limited, can't directly pass throughout the wreckage.
You can see the other devices, advantages, disadvantages.
An example of a seismic acoustic listening device is the Diodes Life Detector LD3. The Diodes Life Detector LD3 transforms the entire collapse detector into a large and sensitive microphone that transmits sounds from disaster victims.
Also here, DKL Life Detector gives an example of radar detection devices.
The Lifesaver Detector comes to the fore with its sensor, microcontroller, and software. In our project, we use Raspberry Pi as a microcontroller. Our sensor doing non-contact breath following. It measures the distance between the person and the sensor. It can measure day and night regardless and measure respiration rate.
The Python was mainly used in this project. So we did our research. So what are the methods we follow in this project? Some tools and equipment were used in this project. These are briefing sensor, microcontroller cards, LCD display, and our power bank. We firstly determined the objects and tools we used in our life detector. We made the 3D drawing of the parts that will form the main body. After we assembled our device, we tried to determine the most suitable and most useful software for our life detector. While doing this, we considered the number of libraries and platforms it provides to other languages and practicality. In this direction, we made it using Python language, which is one of the languages that work most efficiently with the Raspberry Pi.
We created the outer body in order to keep the parts of the device together. We preferred an exterior design that the user can easily grasp and use when entering the rig. There's 3D photo you can see above and the photo of the printout below. As you can see there, we prepared the prototype and that's our device on the bottom.
And I want to show you now our device, and I want to tell you working principle of the device. You can see our device's main body. These are briefing sensor, Raspberry Pi, and the LCD display. These sensors has a transmitter antennas and receiver antennas. Transmitter antennas sends electromagnetic waves, and these electromagnetic waves bounces from the persons and detects from the receiver antennas. And you can see the white cable. This white cable provides the communication between sensor and Raspberry Pi. Raspberry Pi processes the data coming from the sensor, And we can see the victim's display, victim's distance, heart rate, and respiration rate in the monitor. And the researchers have been done a specific method was followed in this project. So what are the findings we detected in this project? First of all, we placed our device and carried out single person measurements without obstructing it. As you can see in the table, the person was detected where the peak of the wave rose. Also, let's say that the wave amplitude changed according to the respiration, heart rate, and the movements of the person in the places where the wave you see in these graph peaks. That is where the device perceives the person.
Measurements for 2 people, which we measured without disabilities, are given here. Out of the peaks decreases after 3 meters. The position in general is clearly visible on the graph. There are measurements of 3 people that we measured without using barrier are given here. It has been observed that the sensor can accurately detect the position correctly.
As you can see in the pictures, a 5 cm barrier was used in our next measurement, and the sensor was positioned 20 cm away from the barrier. As seen in the table, we see that the signal decreases when the barrier is placed and away from the device. We see that the waves peak at the point where the device detects the barrier, but let's say that this peak remains constant. The peaks that occur in detection of a person vary according to the respiration, heartbeat, and the movements of the person.
We used 8 cm thick barrier in these measurements. The sensor is 20 cm away from the barrier. In the first picture, we only see the change created by the barrier in the measurements. We can also observe that the peaks decreases depending on the distance. Here again, we see 2-person measurements made using an 8 cm thick barrier. As you can see, the waves peaked in places where people were present. In other words, our device has detected the person correctly.
In our next measurements, a 17 cm thick wall used and the sensor was again positioned 20 cm from the barrier. Measurements were carried out in 1 person. As can be seen, the signal has increased compared to other barriers. It was observed that as the thickness increased, the signal decreased in direct proportion, but again the sensor was able to successfully detect persons.
Here too, we see the measurements of 2 people standing behind the 17 cm thick barrier. There is a distance of 20 cm between the barrier and the sensor. Thanks to the screen located on the prototype of lifesaver detector, the distance of the person to sensor can be seen. In measurements taken from the computer, the distances corresponding to the peak points formed in position where the person is located are numerically on the screen on the lifesaver detector prototype.
Based on these measurements and researchers, some results have been reached. While there were no barriers in front of the device, measurements were taken with 1, 2, and 3 people. It was determined that the device correctly detected the distance of the person from the sensor, and the amplitude of the wave increased or decreased according to the distance, movement, and respiration of the person from the sensor. Barriers of 5, 8, and 17 cm thicknesses were used. Although the thickness of the barrier increased, the sensor can detect the victim at different distances. It was determined that as the thickness increases, this signal weakens a little, and the range at which it can give clear results decreases to 1.5 meters. For the 17 cm barrier,
It's about the connection, I guess. He will come right now.
my internet connection is has a mistake. Did you see the presentation? No?
Yes, we can see.
Okay. Methodically, research was done, measurements were graphed, and some suggestions were made from the project to be better. The device can be used not only in earthquakes, but also in mine dams, explosion dams, and so on. Different applications can be made in other sectors, such as health sector, construction sector, by adding different sensors to the device. With a larger budget, the range of the device can be expanded by using more sensitive sensor. The device can detect not only the distance of the victim, but also the probability of survival of the victim by checking the frequency of breathing.
Lifesaver detector has easily applicability. It gives clear and reliable results to us because this device can't detect inanimate objects, and it's original. You can also use on mining dams or health sector by improve the device, and therefore our device stands out.
Here are the bibliographies we used in making this project. You can also, the bibliographies in here.
And thanks to listeners.
Thank you for the presentation. Any questions from our experts?
Okay.
Could you explain the detector? What the physical value it detects? Sound or air moving? What is the detector?
Yes, our device works with electromagnetic waves principle. It's when meets the constraint blocks or any disabilities, these electromagnetic waves, some of the parts, these electromagnetic waves absorbing from the disabilities, but some of the parts, this electromagnetic wave passing through the wall and detects from the victims. Bounces and detects from the receiver antennas. You can see there are sensor antennas. This is a sender and this is a receiver. It's not used sound wave.
Sorry, I didn't understand it well. So the patient, I don't know how we could call this, the victim, does he need to keep some device with him?
I don't understand.
Should the victim keep something with them? I don't know.
No. The device detects the locations with electromagnetic wave system, but it detects the heartbeat of the person. So the victim don't need anything about it.
Electromagnetic waves. And
yeah.
What is the wavelength of this electromagnetic waves? What is the length of these electromagnetic waves?
We can reach this because of the sensors. We can't reach them to intent. We tried, but they detect
Understand? You use it as it is, as yes. Ready to use detector.
Yeah.
So it detects electromagnetic waves of body.
Yes.
Of human body.
And detects from the device.
Yes.
Okay. Thank you.
Can I ask another question? It looks similar to Teplavisor. Did you tested some alternatives? And the next question is, what can disturb your signal? For example, what else can produce the same signal? In what cases you can be mistaken?
I can answer the second question.
Yes.
We did our measurements on the different places. We don't problem in here. because of the system's prototypes. I'm sorry, my English not good. But we did. Yeah, I can't translate it. I'm sorry.
Can you repeat the question? Can you repeat it, your question?
Yes. What else can produce the same signal like human body? I mean, for example, using your detector, you can detect something else, not a human.
Okay.
We have a
Our
time to-
device detected the barriers, but barriers is a how can I say? You can see our findings. I will show you.
We have time only for a brief answer. Sorry.
What?
Time is over.
Short answer, please.
This is the obstacle, and this is the living things, and this device detects the barrier, but this wave remains constant. When detects the living things, the device, these waves. How can I say, change to the depending on the people's or victims' heart rates, movement, and the respiration rates.
Okay, thank you.
Okay, thank you for your presentation. Our next participant is from Israel. Tamar Osfer, it's your time. Thank you for your presentation.
You're welcome.
I'm the CEO of Bikes from the Green Start Academy in Akfar Yarok, Israel. We're going to start with a short video, and then I'm going to present a little. Can you hear it?
Not really. There is an instruction how to share sound in the chat.
Oh, I'm sorry, just a second. Okay, I'm very sorry for that. Okay.
Many children promise their parents they wear a helmet while riding a bike. But do they? The helmet reduces risk of serious injury by 70% if there is an accident. But still, less than 30% of bicycle riders wear a helmet. Meet Bikes, a system that can detect if the bike rider is not wearing a helmet and activate a loud beeping sound from the bicycle as a reminder. The system also includes the option of downloading an app that alerts a parent or another relative in case the bike rider has no helmet on or in the event of an accident, with an optional GPS location. Our technology is reliable, easy to install, cheap, and hard to bypass. For more information, contact us on social media. Bikes, Bike Smart.
Okay. So only 18% of cyclists wear a helmet while riding. Every year, about 254,000 people are injured from bicycle-related accidents, and over 40% of parents aren't sure their kids are wearing a helmet. The helmet reduces injury by 70% in the event of an accident. Wearing a helmet saves lives. So meet Bikes. Our system can detect when the rider rides with no helmet and starts a reminding beep. This is very similar to when you don't wear a seatbelt, for example. In addition, there is an option of downloading an app for the parent's phone. This app will allow the parents to get different information about the kids while they ride, including whether they wear a helmet. The system also has a fall detection mechanism that can contact a relative or an emergency center in case of an accident. The system has three components: a helmet add-on, a stationary device on the bicycle, and an optional app on the parent's phone. You can see here our second POC. Those three components detect two main parameters. The helmet add-on detects if the helmet is on, and the device on the bicycle detects if the wheel is spinning. In the helmet add-on, there is a mechanical press sensor. The helmet will only turn on when this sensor is pressed. Once on, the add-on will check whether the thing pressing the button is a real head. To do that, we're using a capacitive sensor, which can detect a human touch, even through hair or a hat. You can see the self-press sensor we developed on the left, and a drawing that explains how capacitive sensor works on the right. When the add-on confirms a head, it will send a BLE signal to the bicycle device. The static device on the bicycle is similar to a bicycle speedometer. It's using a Hall effect sensor, which is a commonly used technology in this field. A Hall effect sensor can detect a magnetic field. If the device is detecting that the wheel is spinning, it will check for a signal from the helmet. If there isn't one, it will start a reminding beep, and it can send a notification to the parent's phone using a long-range cellular communication. We provide a fall detection as well, with an option of GPS ongoing monitoring and an option of making an automatic contact with an emergency center. Like many products on this market, we're using an IMU model that contains a gyro and an accelerometer. The IMU model also used to make sure the helmet is not upside down. This is another function to make cheating harder. In the app, you will find information about the system. For example, if the battery is low or if there are any technical issues. The parents can choose what information to enable according to their needs and principles. For example, GPS location, the distance the rider rode every day, if the rider wears a helmet, and more. So about competitor analysis, surprisingly, there are no products such as ours on the market today. Although there are several entrepreneurs that are trying to address some of the issues handled by bikes. For example, we have an Israeli entrepreneur called Itai Matitial. He developed a product called Click It On. That is a mechanism for only an electrical scooters and bicycle, and it does not unlock the scooter until the rider wears a helmet. We have some a lot of technical advantages on this product, along with some features that we have and this product doesn't, like the app and fall detection. Another competitor is VioRide, that is a scooter that uses image processing. And like Click It On, it doesn't unlock the scooter until the rider wears a helmet. So we're not using image processing because this is a very difficult and expensive technology. And also our device is a small add-on and not a whole scooter. Okay, so this is not the main topic of this competition, but I do want to say a few words about our business model and financial plan. We're going to sell the product as an add-on, suits for an existing helmet. Production cost is estimated to be about $20 a piece, and this is in a modest production capacity. We plan to sell the basic product in a price of around $60 to $70 to the customer. With optional features, it goes up to $120. Our marketing strategy include crowdfunding as a marketing channel and strategic partnerships with helmet and bicycle manufacturers, insurance companies, and bicycle distributors. About our financial plan. For the next eight months of operation, we're planning on crowdfunding from crowdfunding platforms, about $1,500 to $3,000. It will be used for production of about 30 pieces. We estimated that to take about $900. and a small marketing campaign, which is estimated to be about $600. We expect to sell the product for about $60 a piece via our website. We want to go through our milestones. Up until now, we've been working for about 2 years. We have a second POC development, and we're working on IP registration. We are planning on starting silent sales by October, and then we'll be tracking the data and collect the data. And then according to that, we're going to do a second development round. About our company status, as I said, we have a second POC. We've been on national TV. We're working on IP registration. We went on finals of the biggest startup competition in Israel. And right now we're also competing the same competition this year. And that's it for the company status. About our team, we're a team of 5. We're all dedicated to our shared goal, makes bicycle riding much safer. When we created the team, we made sure that each of us has a different and complementary strengths. So our team is diverse and we have every skill that we need. Each of us has a well-defined role, and that is why we work so well together, along, of course, with our great friendship. So if you have any questions, I'd love to answer them.
Thank you for your presentation. Maria, you can ask your question.
Yes, I have a question. Could you show a prototype of your device?
Yes, just a minute. Here.
Oh, okay. I missed it. Is it too complex for it function? So you're making a device that have many functions that requires an app and
there are many products. Sorry.
I mean, probably people will not use these complex functions, complex device.
Okay, so there are many products that are very similar to this model on the market. For example, speedometers is also they look like that with the stationary device on the bicycle. Obviously, all of the wires will be better. This is just a POC again. The helmet will be a little tricky to install, but we're planning on selling this product through bicycle stores, and we're planning on letting all the sailors know how to install it and help people if they need any help. Also sell this product along with the helmet. This is a marketing strategy that we're planning on.
Maybe I missed. Do you block a wheel when a person without helmet, or he still can use a bicycle?
I didn't really understand the question, but we have multiple functions.
I mean, is bicycle blocked until the user wears helmet or not?
No, we found that option a little too dangerous and also complicated because, for example, if the bicycle suddenly locks while the rider is riding, but we have a beeping sound like when you don't wear a seatbelt. So no one wants to ride a bicycle that has a loud beeping sound. And also we have an option of sending a notification to the parent's phone. And that is also a function that will make people wear the helmet.
Okay, so this device for parents who cares about their children.
Yes.
Okay.
But also for adults that don't want to forget to put their helmet on. This is another option because the app is only optional.
Okay, thank you for the answer. We have two questions from our experts. We have to keep it brief because of time saving.
Okay.
Valeria.
Okay.
You can.
Hello,
Valeria, you can-
Tamar.
you can-
I have one question. Do you have any remote inactivation of beeping sound? For example, if something goes wrong and it starts alerting without any reason?
Through the app, the parent can
Yes.
disarm it, and there's also an option if the parents trust their kid, they can have the option of the kid disarming the beeping sound from the bicycle with a button.
Okay, thank you very much.
Your sensor detects the wheel moving using electromagnetic detector. And if I just cover the sensor by, I don't know, a part of metal, so the system will detect the wheel as standing, not moving. So there will be no any device. Do you have some kind of protection and
Yes.
more protection models?
In the app, there's an option of seeing how many kilometers the kid rode every day. And so if the parents wish to check if something is wrong, they can see if they know the kid went on a ride today and it shows 0 kilometers, so there's obviously something wrong.
Good, good. And do you talk with rental services, because bicycle rental services could be one of the big buyers of your system?
Yes, we actually thought about that, but in Israel, a new law just came out that all rental bicycle has to have helmets next to it. So a lot of companies are working on something like that, and then they won't need our product.
Okay, thank you.
They'll probably have helmets that are tied to the bicycle.
Thank you.
Okay.
Thank you for your presentation. Thank you for the questions. Our next participant is from Latvia, Krišjānis, if I spelled it right.
Hello.
Hello. You can start.
Okay, so give me a second. Okay, can you see the presentation? Okay, so can you see the presentation? Can I start? Can you see the presentation? Can I start? Does anyone see the presentation? I need a confirmation.
Yes, it's okay.
Okay, thank you. Okay, so my name is Krišjānis Lūns. I am representing Latvia today with my research paper on aerospace rocket engine thrust vectoring systems. Okay, so now the goal of my project is to create a thrust vector control system alternative for solid fuel aerospace rocket engines. And now in order to do that, to complete this objective of mine, I needed to first study some rocket science basics. Now, the first thing you must understand about rocket science is Sir Isaac Newton's third law of motion, which says that every action has an equal and opposite reaction, meaning the amount of thrust that a rocket generates is equal to the energy at which it expels exhaust gases from it. Now, once we understand that, we can also start to understand how it is possible to maneuver a rocket during flight. Now, the thrust that it generates by shooting out exhaust gases out of it, it creates a line of thrust or a thrust vector. Now, if this thrust vector is running straight through the center of mass of a rocket, it will fly straight. But if there's an angle by which the thrust vector is offset from the center of mass, the rocket will pivot in the opposite direction. So this is how rockets can maneuver during flight. Now, the next thing that must be understood is how to generate this thrust. And in chemical rocket engines, the way it's done is by accelerating the exhaust gases to a supersonic or a hypersonic speed. Now, in order to do that, you need a convergent divergent type nozzle, which takes first the gases that are produced by the chemical reaction. First, they are subsonic, meaning below the speed of sound. And the nozzle, it converges by decreasing its volume until the point where the gases reach exactly the speed of sound. And at this point, an interesting thing happens in fluid dynamics. Once a gas reaches exactly the speed of sound, then after that happens, you can increase the volume of the nozzle, which will, instead of decreasing the speed of the gas, will increase the speed of the exhaust gases. And this is how rocket engines can create massive amounts of thrust from their chemical fuel and oxidizers. Now, how an aerospike rocket engine differs from a standard bell-shaped nozzle, which you most likely have seen as it is the most prevalently used one, is that on the screen you can see in the picture there on the left side, there is sort of a spike-shaped object in the middle of the diagram on the bottom. Now, what this does is the spike that extrudes out of the outer edges of the nozzle quite a bit, it will continue accelerating the exhaust gases further out. Now, after knowing these things, I had to find a solution to the problem of creating a new alternative thrust vector control system for solid fuel aerospike rocket engines. Now, the solution that I came up with is that instead of gimbaling the engine itself, I decided that it would be possible to change the thrust vector only by gimbaling the spike itself. And the reason why it works, and if we look at this image again, the gases that flow nearest to the spike, they are accelerated further and further, and their pressure decreases. As a gas accelerates, it decreases in pressure, which means that the outside gases are pressed upon it, and it will form a shape that resembles the spike, meaning the exhaust gases will follow the spike and thrust vector as well. Now, in order to test this theory, this hypothesis, there was a necessity for using a rocket fuel. Now, in this case, I didn't pay that much attention to the rocket fuel. The one that was decided to be used was a potassium nitrate and sugar rocket fuel, which is readily available and easy to use, which is why that was the chosen one. Now, of course, there was also a necessity to create a prototype rocket engine. Now, for this, I wasn't able to do it myself. I ended up getting a sponsor, which it was a company that specializes in metal work. And together with them, I was able to create a schematic that they were able to turn into an actual rocket engine. Now, obviously, there's also a necessity for a way to test this hypothesis. And for this, there was created a test stand device, which measured the sideways oriented thrust, or in other words, the change in the thrust vector. Okay, so in the testing, the photo on the right shows the rocket engine placed upon a test stand, which has the rocket engine facing upwards. And the way it was activated was at first with slow burning fuses, which you can see on the left side of the screen. But later, There was also implemented a system where the engine could be activated from afar by heating up a metal spool from a distance by applying current. Now, during these tests, data that was gathered looked something similar to this. Now, what this diagram shows is change in sideways oriented thrust, or a change in the angle of the thrust vector. Every peak and valley is a change in the direction of the thrust vector. Now, what this shows is that it is actually possible to control the thrust vector of an aerospike rocket engine only by gimbaling the central spike. Okay, thank you very much for your attention.
Thank you for your presentation. Our experts have any questions?
Have you made any prototype of your device?
Yes, the device that I showed in some of those final images was a prototype rocket engine. I also had a test stand.
Yeah, so, and what is the limitation of it?
Personally for me, or for the design itself? I'll answer both questions. For me personally, I don't have the resources to create expensive and greatly capable rocket engines, as I am only a student. For the design itself, there are new technical limitations, so to say. The design from which I took inspiration was one where the entire engine itself is gimbaled. What I changed is that only the central spike is gimbaled. Basically, what that means is that in some rockets, it will be easier to create a system, a hydraulic system, most likely, a gimbal the central piece. And in some engines, it will be easier to create a hydraulic system that gimbals the entire engine. It mostly depends on the rocket itself.
What? Sorry. What angle? What the maximum angle could be corrected using by your method? Because I think there should be more limitations, more limitation for your method instead of moving nozzles.
Yes, of course. So in the original tests, we were able to create an engine that gimbaled about 2 to 2.5 degrees, which was able to produce about 10 newtons of sideways oriented thrust, which is quite good. In some hypothetical engines that I've dreamed up in my mind and also put on paper, the maximum angle could be up to 10 degrees, but that would be quite complicated and so on and so forth. But another implication of this thrust vector control system would be combining it with a gimbal system that gimbals only the center piece. Let's say, for example, if you gimbal the entire engine, it creates 10 degrees of, you can gimbal up to 10 degrees, and then the central spike can gimbal 5 degrees. You could create an engine that gimbals up to 15 degrees. So it could also be implemented, both methods can be implemented in one system.
Thank you.
Thank you for your
Okay.
question.
Can one question?
We have 1 minute.
Okay. Thank you. How many nozzles does your engine contain?
Come again? I didn't quite understand.
How many nozzles does your engine contain?
Okay. Yes.
2, 3, 4, 5, or more?
In most rocket engines contain only one nozzle. Okay, we must start by defining what a rocket engine is. In most definitions, a rocket engine is the fuel flow cycle, which means in all solid fuel engines where the entire cylinder is filled with fuel, there can only be one nozzle. In some liquid aerospace rocket, in some liquid rocket engines, it is possible to also have multiple nozzles. But in solid fuel rockets, it's only one nozzle for one engine.
You used in practice your assumptions, and if you have you some videos or some results of measurements?
We have measurements. I showed the diagram. As far as videos, I didn't include them in the presentation, but I have recorded some videos of the engine firing.
Thanks.
Okay. Thank you for the presentation. Thank you for your questions. And our next participant is from Spain, Ramiro Valdez, if I spelled it correctly.
Hi, hello.
Hello, you can start.
Yes. Okay, so first of all, thank you so much for selecting me for this contest. And I'm going to play a video of my presentation, a PowerPoint video. So I'm going to share my screen. Okay. Can you see it?
Okay, we can see.
Okay, so I'll go.
Is there any sound? Because we cannot hear.
Yes, sorry?
Is there any sound in your video? Because we cannot hear.
You cannot hear the sound.
Yes, we cannot. You should start the presentation with sound check. We will resend the instruction.
Sorry, I don't understand. So
you should start the screen sharing with the sound sharing option. I have resent.
Okay. Let me see.
You should hit the checkbox screen sharing to share sound.
I don't know. It's not working. Let me try again. So you cannot hear anything?
We cannot hear.
Wait, I'm trying. I don't know what to do. Now, let me. Okay, now. Liz from Tres Cantos, Spain. Can you hear now? Hello, good afternoon. My name is Ramiro Valdez.
Yeah, we can hear.
From Cantos, Spain, and today I have come to present my project to you. Transition to photovoltaic solar energy in IES Pintor Antonio López, Tres Cantos. So first, we will talk about the objective of the project and the causes that led me to do it. Next, we will move on to the photovoltaic project, carrying out an analysis from 3 points of view: technical, financial, and environmental. Next, we will study the business opportunity presented by the photovoltaic project, as well as a simulation of a private company and the generation of profits. And finally, the conclusions that I obtained based on this project. So, the objective of this project is to demonstrate the technical and economic feasibility of implementing a photovoltaic installation in a school. So the reasons that led me to do it were, first of all, as we all know, global warming is considered the most important challenge, and for this reason, society requires an energy transition, betting on renewable energies. So the project is in the city of Tres Cantos, which is about 30 kilometers from Madrid, Spain. The coordinates are important as they will determine the solar quantity received in the location. We will move on the photovoltaic project. The current Spanish photovoltaic regulation resides in Royal Decree 244/2018, 2019. It includes modifications such as administrative simplification and especially the annulment of the sun tax. In addition, a compensation system is introduced that allows surplus energy to be poured into electricity grid. Then, moving on, an analysis of a current electricity bill is performed. Then, the electricity bill is contracted with hourly discrimination, so that 3 billing periods are different during a day, being night period, valley, which is the cheapest period. Then among the most important terms of electricity bill, they are the fixed part, which is the power, the amount of energy that can be used in a specific time, and the variable part, which is the consumption we do. So making, if we see, making an estimate in which the monthly bill is constant, the total annual expenditure on electricity bill is 3,200 euros. So, moving on, to carry out a photovoltaic installation, it is vitally important to know the amount of solar energy in the location. For this, I use the PBGIS application, which is a satellite geographic information system, which allows knowing the solar irradiance at the project location. Then, the inclination of the photovoltaic panels depends on the position of the sun. So, at the location that we're making this photovoltaic installation, the optimal angle that maximizes the solar resource obtained is 36 degrees, as we can see at the right. But during the winter months, it presents a much greater difference than the summer months. So more energy would be needed from the grid in winter, or there would be a lot of energy left produced in summer, which one we use. So if the cell price is lower, I decide to use a 50-degree slope, which, despite having less annual solar resource in total, favors the obtaining of energy in winter months and does not produce excessive surpluses in summer. Also, there are some photovoltaic panels that follow the path of the sun, but their high cost would mean a decrease in economic profitability, so I decided not to implement them. There are 2 types of photovoltaic installations: isolated installation, not connected to the electricity grid, and the grid-connected ones. And due to the high cost of batteries and their legal changes, I decided to use the grid-connected installation. Then, to select the elements, my elements were based on the company Autosolar, just as a reference. And through estimates that the center consumes around 270 kilowatt-hours per hour during the elective days, the school days, I chose a kit which requires an initial investment of 48,000 euros, and it has 25-year warranty, which will be the duration of the project. Then in the graph, we can see the productions of the photovoltaic kit. The red line delimits the consumption of the center. Based on the production shown, the resulting electric bill after the application of the photovoltaic installation is divided into 2 blocks. The months that do not require electricity supply from the network, months close to summer, and those that they do. So in the winter months, the fixed part will be higher and the variable part as well. Adding up all the monthly bills, we can conclude a yearly saving of 10,000 euros, which is produced in the electricity bill compared to the previous one that I showed. So for evaluating a project, I used some economic criteria, which were the net present value, which consists of updating receipts and payments of a project, and in this case the interest rate used is 5%, and the period is 1 year. So when the net present value is greater than 0, it indicates that the investment generates benefits. The internal rate of return, which is defined as the value of the discount rate that makes the net present value equal to 0, and if this internal rate of return is greater than the discount rate, in this case 5%, the project exceeds the minimum profitability required. Also, I used ROI, which is return on investment, allows you to know how much of each euro invested in a project has generated in sales. If it's very close to 0, profitability would be minimal. So as greater as it is, the best. And then Finally, the payback. Payback or recovery period is defined as period required to recover the initial capital of an investment. So logically, an investment where the recovery period is shorter will be preferable. To analyze the profitability of the photovoltaic installation, duration of project 25 years and the initial investment required of 48,000 euros must be taken in account. So the cumulative gain with an interest rate of 0% without the net present value is represented by the blue columns, and on the other hand, the benefits are applying the net present value is 142,000 euros. So the internal rate of return is 23.86%. It's a high profitability, almost 5 times the one used. The ROI and payback indicate a return of almost 300% on each euro invested, and the date from which the investment has been recovered, profits began to be generated. It is 1/5 of the duration of the project. So after having analyzed these economic criteria, it is concluded that the project is profitable. Now, the possibility of oversizing the photovoltaic installation is also considered. For this, it would be needed a 20 kV kit added to achieve the energy consumed annually during all months of the year, as you can see in the graph in the left. This leads to a higher annual saving of $300,000. After performing the calculations, we obtain an increase in profits of $16,000, but almost $16,000 have to be invested to purchase the kit. So the internal rate of return is close to the one used, which would mean a decrease in profitability and a high financial risk. So it was decided not to oversize the installation. Now we're going to analyze the environmental impact that the transition to photovoltaic energy would entail. Currently, in a period of 25 years, the center consumes 2,120,000 kWh, which represents 869 tons of CO2. But if we use the photovoltaic installation, we would save 632 tons of CO2. So this figure is equivalent to 5,300 trips by Madrid-Barcelona in car of one passenger. So now we're going to analyze the private company simulation. After the completion of the photovoltaic project, a business possibility is observed, because despite its high profitability, it is an investment that requires a costly initial investment. So after studying the economic regulations that govern public centers in the Community of Madrid, due to the difficulty of indebtedness of a public entity, the idea of creating an intermediary private company was born that would offer the center the possibility of a transition to photovoltaic energy. The center is offered a percentage discount on the electricity bill for a period of 25 years, which is the duration, at zero cost for the center, and then the company would charge the energy consumed to the center, applying the tariff terms of its electricity company, explained above, with a discount, which would increase progressively over the 25 years to reduce the financial risk of the investment. As an example, the high school Pintor Antonio López is used. A 10% discount is offered that will generate an approximate savings of 43,000 euros. So in exchange, the center has to allow the company the possibility of implementing the photovoltaic installation. The benefit is twofold for the center. On the one hand, the center reduces the monthly cost of its electricity bill, and on the other hand, by using green energy, it will benefit from an improvement in its image with regard to environmental policies. So the profits of the company come from the profits produced by the photovoltaic installation, discounting, in this case, the 43,000 euros saved by the high school. So the selected financial criteria show profits of 99,000 euros and an internal rate return of 15.5%, which is 3 times the minimum required return. Therefore, it is concluded that it is a profitable project for the company. Finally, the conclusions. So we set ourselves as an objective for as an objective for this work the hypothesis of demonstrating the viability of the transition to photovoltaic energy in the IES Pintor Antonio Lopez. Regarding this, it can be concluded that the project is technically and economically viable for the following reasons. The technology of photovoltaics has experienced a big evolution, making it easier for such projects so they can have benefits in the short term. And in addition, the unquestionable repercussion favoring the medium environment and reducing the CO2 emitted into the atmosphere. Also, changing the regulations of consumption energy in April 2019 has benefited the viability economic of the project, since its numerous changes that introduced. However, there have also been some limitations, such as the difficulty of having consumption of the center in time slots. It would have been convenient to have a meter in the electrical network to know hourly consumption. In this way, the calculations made would be more precise and the error rate would decrease. Also, I would like to add a final thought. I would like to highlight the importance of an economic and financial analysis in the evaluation of long-term technical projects. So, thank you for listening to me, and also to the contest for having selected my project. Thank you for your attention.
Thank you for your presentation. Any questions from our experts?
Yes, I have a question. The main question, what is the result of your project? Could you conclude?
Excuse me, can you repeat?
What is the main result of your project?
So, I would highlight the main result of this project is to show that it is possible that, in this case, high schools and all buildings of a government, such as high schools, it could be another thing, that they can have the possibility with a creation of a company to have a solar resource instead of consuming CO2 and giving more CO2 to the atmosphere. The result is to show that it is possible and it is also profitable, economically talking, you know. So that is the main result I want to show.
I have a question. Thank you for your presentation. Can you explain if you are intending to completely use solar system for powering those buildings that you've mentioned, or you are planning to have a mixed hybrid grid and the solar?
Okay, so I think that was my fault that I didn't make myself clear in the video, but I was looking for the best profitable option because I have two options: the network connection by also using solar panels, and the only ones that and another possibility that was only using solar resources. But in terms of economic profitability, it was better since batteries have a high cost to use a solar resource, but as well be connected to the network. So in this case, the result would be a hybrid method.
So if it's a hybrid, then at any given time, how would you ensure that the green energy, so to say, is used? Is there any way that you can monitor or for example, create some kind of data process that will basically mark the green energy that you are generating, as to compare to the one that you will be getting from the grid? How will you differentiate between the energy source?
So these solar kits of those companies, they are programmed, I mean, to use at every moment, if they have the possibility, the green energy. So if you are connected to the network and you don't have enough green energy for a specific moment, that's when they start to get the energy from the network, and that would mean an increase in the electricity bill. But otherwise, if it was possible, that was the possibility of oversizing the photovoltaic installation. They wouldn't use network electricity at all. So the solar kit is programmed itself to use green energy whenever it's possible.
Okay, thank you.
Thanks for the question. Any other questions from our experts?
Okay, thank you.
Were there any other questions? Well, anyways, thank you for your presentation. I would like to thank all the participants for their reports, and a special thank to our jury members. The next meeting will be on April 14 at 1 p.m. Moscow time. Thank you all.
Thank you very much.
See you later.
Thank you very much.
See you.
Bye.
Thank you. Bye.
Wednesday.